Good morning, everyone. Welcome to today's Meeting of the Minds webinar. The title of our webinar today is Smart Communities, How 5G, Mobility, Vision Zero, and Multimodal Approaches Are Converging. During each of our webinars here at Meeting of the Minds, we take a reading on who's joined us. So you'll see a poll that just popped up asking you which sector best defines you, and that helps us, so please fill in that poll. My name is Gordon Feller, and I'm a board member and a co-founder here at Meeting of the Minds. Our organization is a global thought leadership network and platform for knowledge sharing with a year-round digital and in-person programming that we provide. Our nonprofit connects global urban sustainability, innovation, and technology leaders across sectors to share best practices, to share tools and solutions through our blog, through our monthly webinar series, and more than 20 events each year. You can find all of our upcoming events, including these webinars, in the events section of our website, meetingoftheminds.org. Now, a few housekeeping notes to begin. First, because of the large number who are in attendance today, you'll remain muted throughout the event. And thanks for joining us. Today's slides and a recording of today's webinar will be available on our website after the event for you to share with colleagues that couldn't make it today. So you can find today now on our control panel, the GoToWebinar control panel, both of the presentations as PDF documents. That's in the handout section in the control panel, which you can download. We will have, after the two presentations, a Q&A during the second half of our hour. When you have a question, please type them into the questions panel in your control panel, just as you think of them. So here are the results of our quick poll. We'd appreciate your input throughout during today's webinar and especially after. So a short survey will pop up when you close your browser at the end of the event. So please be sure to also respond to that. Now, I'm pleased to introduce our two presenters. The first presenter today is Sean Harrington. He's Verizon's Vice President of City Solutions, Smart Communities, and Venues. He joined Verizon through the acquisition of Sensity Systems by Verizon in October 2016. Sean was the Chief Operating Officer for Sensity, where he was responsible for the operational and strategic leadership of Sensity, and he's joining us from the Silicon Valley offices of Verizon. Following him will be Brenna Berman. She serves as Executive Director of the CityTech Collaborative, an Internet of Things urban infrastructure lab that transforms cities into test beds for new ideas. CityTech remakes essential services and infrastructure from skills to skyscrapers and then expands those solutions to other cities, thus increasing the world's odds of solving the big urban problems we face. CityTech is currently easing subway congestion during large events. It's creating a digital map of Chicago's underground, and it's launching a digital directory of public health services in Chicago. Prior to joining CityTech, Brenna served in Chicago Mayor Rahm Emanuel's administration, which she joined in 2011. She served as the Chief Information Officer for the city and the Commissioner for the Department of Innovation and Technology, and that was from 2012 to 2017. We're really honored to have both Sean and Brenna, and now Sean, pass the ball to you for your presentation and discussion.
Thank you, Gordon, and good morning and good afternoon to everyone. I know everybody's excited about 5G and how it can transform the way we live, work, and play in cities, and for good reason. I will get to that in a moment, and especially focus on the mobility sector. But I think it's important to first set a bit of context of some of the other trends that we see in the smart communities space, and in particular in the mobility space, because they are highly connected with what we see as the opportunity with 5G. As Gordon mentioned, I lead product development for the smart communities team, and so whenever we think about technology, including 5G, we really focus on how we can deliver outcomes against the major pressing challenges that most cities, if not all cities, face. Including mobility, but also public safety and security, sustainability and efficiency, as well as digital inclusion and digital equity. Because we all know that technology is just a tool, and we're using technology because we want to improve the way we live in cities, whether that be reduce the number of fatalities, the 40,000 people who die each year in cars, or the collective 8 billion hours that we all spend in the U.S. stuck in traffic. These economic, environmental, and societal challenges can be addressed through a lot of great technology. And if we step back just a minute and look at where we've come on the smart communities front, we started with really a very basic concept, which I call the first generation of smart communities technology, where we really put a radio and an IP address into a device that was already operating out in the field, like a power meter or a gas meter at somebody's home. This turned into, the smart meter movement. But really, we weren't doing anything other than operating an existing device remotely in a similar way as we had previously, but through human intervention. But of course, times have changed dramatically, and what we have seen over the last 5 to 10 years is this massive proliferation of sensors, new sensors deployed to solve challenges that weren't deployed previously, whether that be audio devices deployed to detect gunshots, or the cameras placed on vehicles to monitor traffic in real time, or video cameras on light poles detecting the movement of traffic and pedestrians through intersections. And I realize that this amount of data is not really comprehensible for anyone that's 2.5 petabytes per day. But the way I like to think about it is that the fact that in the next year and a half or so, we will generate about as much data as was generated in the history of the world up until this point. So that's what happens with this exponential increase in the amount of data. And importantly, I think what we can all agree on here is that it's not just about the data, it's about converting that data into actionable insights. And that's not, it's easy to say, but it's very difficult to do. And that's where we start to really see some of the opportunities that I'll talk about in a minute on the 5G front. But what's important here is to be able to leverage all of the advancements that are happening in machine learning and AI to take that raw data and do accurate predictions so that we can take actions that help deliver the outcomes that we all want. And that's not done in a vacuum. These systems now are becoming increasingly interconnected. So while up until this point, if there's an accident on a road and you're using a navigation app like Waze or Google Maps, to find your way to your destination, when an accident comes up, it may direct everybody, through that same detour. Whereas, and those sort of individual vehicles are islands analyzing the situation unto themselves. We see lots of opportunity for those systems to be communicating between each other and directing some vehicles down a particular detour and others down another, so that we're not just moving the congestion from one place to another. And so really what comes with sensors is the need for the ability to compute the raw data and turn it into actual insights from the device to local distributed computing all the way up to the cloud, depending on the situation. One example that we like to share that really is a good example of how this is happening is sensors that are deployed with lights. There are about 4 billion outdoor lights. They're all being upgraded to LED. We're about 15 to 20% through that process. But what we see is universally now, cities around the world looking at that upgrade to LED as an opportunity to deploy sensors, and in particular, a very strong interest in using video as a raw sensor. Given how powerful video is, you can see from this clip the ability to classify and track objects in 3D time and space, such that a near miss, which would not be easily detected between a car and a pedestrian with sort of traditional in-ground sensors or induction loops, can be detected when you use a sensor that is as information rich as a video sensor. And today that's being done in the camera with many systems, where the raw video is converted directly to the classified object and its location, and then sent to an application running in the cloud that utilizes that data and the video doesn't get transferred. But what we see is opportunities to, adjust that model as 5G is rolled out. And so in sum, sort of where we are today is a set of applications that are leveraging sensors with compute that is spread from the device up to the cloud across some type of network, both wireless and wired, in order to deliver on these use cases. So, how does that manifest with some specific solutions? Traffic data services is one example that we see, playing an important role. This is using network data, so not any other deployed sensors, but simply the data that is coming across cell phones and tablets that are moving throughout a city, and then being able to correlate the signature of the data that's coming off those devices with specific road segments, and then aggregating all of those pattern matches with specific road segments to give very precise information about what quantity of people are traveling from a given origin to a specific destination, which again is very difficult to do with traditional sensors like in-ground sensors or induction loops, and at the same time is aggregated from any individual information such that data privacy is protected. Another example is Vision Zero and a focus on reducing pedestrian deaths at intersections in particular, and using the type of video and computer vision that I showed a moment ago to be able to report on those key metrics like walking outside of the crosswalk, near misses, turns on right-hand turns on red lights, so that those who are making policy decisions about how to improve safety at intersections actually have the data that they need to be able to assess where their best opportunity is to make changes, as well as then track improvements when those changes are made, whether they be to put in a barrier or increase the number of citations for jaywalking. And again, this follows the paradigm of deploying a sensor, in this case, video sensor, out in the intersection, a set of video sensors that are then tracking all of the movement throughout that intersection in real time, and then delivering over the wireless network the data to a SaaS-based dashboard that is reporting in real time and can provide historical reports as well. So this is where we are today. Now, 5G. How does this come into play? What are some of the things we're seeing? And of course, we could spend hours talking about the opportunity for 5G. And I know that most of you, are familiar with it, but I'm going to take a minute on just what we at Verizon believe is important about 5G, and then how we see it, what the opportunities are in mobility with some very specific use cases. So Hans Vestberg, our CEO at CES this year, talked about the 8 currencies of 5G. And it's important because it's not just about any one of these characteristics. It's about looking at them holistically and saying, in my particular industry, in this case mobility, what is the opportunity to benefit from an order of magnitude greater data throughput or an order of magnitude lower latency? And what we found is that when we sat down and we looked at intersection safety, so Vision Zero initiatives, as well as CV2X, cellular vehicle to everything technology, there was a ton of opportunity to address use cases that wouldn't have otherwise been possible. And for us, the 2 main currencies that we really see a tremendous benefit from are throughput and latency. And again, if you've missed it, I mean, we're not talking about half measures here. This is an order of magnitude increase in the quantity of data that can run across the network at any given time, which means that we can use video sensors in completely different ways, for example. So processing video coming from vehicles that have sensors deployed from the infrastructure, so at the streetlights as referenced earlier. Now, running that video across the wireless network becomes entirely cost-effective and practical and that means the ability to, remove some of the compute-intensive requirements on the device into a more centralized location. In a similar way, latency becomes tremendously important when it comes to mobility, because we have a matter of milliseconds when it comes to opportunity to save lives, whether it be the stopping distance when it comes to automated braking and potential accidents, or better timing traffic signals to avoid issues like the dilemma zone, where you have a vehicle traveling quickly and approaching a light that changes from green to yellow, and the driver has to make a very challenging decision about whether to brake aggressively or to potentially run the red light, both of which are dangerous when, with the latency reduced significantly, we can adjust the timing of the signal to avoid those situations. So throughput and latency, it's only possible if we do all of this, and we're out there throughout the U.S. deploying this technology. It's not a simple process, and it's not all created equal. So when we talk about 5G, we're talking about all of these components, including the edge compute, where we're deploying centers for processing data in real time that is very close to the edge of the network as opposed to completely centralized. Okay, so what's one example? Enabling V2X, I referenced this. Here, what we see as an opportunity is to leverage two main components here. The 5G connectivity between sensors that are deployed both at vehicles and at traffic lights or on street lights, and be able to run the raw video back to the MEC and process it in conjunction with other data like real-time HD mapping, such that the situational awareness for a vehicle is extended beyond the line of sight of that vehicle. Because what we know right now is that the auto manufacturers, along with those developing the autonomous mobility software stacks, are focused on leveraging the sensors that they have in the vehicle, which is understandable, and they've got to reach a certain minimum level of safety with the sensors that they have available only through the vehicle. But we also know that that the safety level will be further increased if the data from the infrastructure can be leveraged as well. And that is only going to happen in a world where we have the ability to push vast amounts of sensor data across that network in real time, in low latency, and be able to process it as close to the vehicles in the edge as possible. If we don't do that, then we're simply not going to realize the objectives of this movement toward autonomous mobility. So I'm not going to go through all of these, but just to give you a sense of some of the use cases, I'll pick a couple of here. But there are tables and tables like this with different use cases, and what we have done is map them such that we know which ones will require 5G versus 4G, and which will require MEC, the mobile edge compute, and which are not possible if you don't have the data coming from the infrastructure. Meaning, if you don't, without non-line of sight sensors, it just wouldn't be possible. So what's what's a good example? Well, take use case number 3, the VRU, the vulnerable road user collision detection. As a driver, of course, you can see what is in your line of sight, whether you're a driver or it's an autonomous vehicle, but you can't see what's around a corner. You can't see what's going to jump out from between two vehicles. And so the industry overall is standardizing on a set of messages that can be delivered to the vehicle from data either provided by a mobile app with GPS location, or that is detected through some other sensor like that video sensor I mentioned, and delivers the message in an automated fashion such that the vehicle can then react, and with the latency that's required to avoid an accident. So as you look at that list of use cases, of course, they can all be visualized. And what's happening now is companies like Verizon, who are both investing in 5G, but also in our smart communities related services, are working with the signal control companies and working with the car OEMs and the developers of the autonomous mobility software to prioritize these use cases and then validate them in real world environments and test in laboratory environments. And that's what we're in the process of doing. So, and this I think just gives a very clear example of the vulnerable road user that I mentioned, and is squarely in the category of achieving our Vision Zero objectives in combination with this transition to autonomous mobility, but is to be able to provide this real-time situational awareness so that we can provide an automated and very low latency response. I was going to mention Sacramento. I've got a slide at the end on Sacramento. The reason I bring up Sacramento is because we are taking these use cases that you saw on the table and in the diagrams and putting them in real world environments. One of those first real world environments is the project that we have with Sacramento, where we have deployed 5G. It's one of our initial 5G home cities, and we're utilizing the same network to transmit video at an intersection to some edge compute, and then deliver a message to a vehicle. And we're in the process of deploying that specific use case now to validate some of the assumptions that we've seen on paper and in some initial modeling. So this is just starting to happen in real world environments. Related multimodal, what we're seeing in the opportunity for 5G here is that as the mobility service providers are deploying scooters or operating ride sharing services like Uber and Lyft, dockless bikes, dock bikes, the cities are increasingly looking for an ability to be able to understand what's happening in real time and monitor whether those mobility service providers are meeting the policies that they've set forth as the city and that the mobility service providers have agreed to. That's happening in part now through an initial movement to standardize on an MDS, a mobility data specification standard, and with 5G, the opportunity we see is to augment that MDS concept with other data sources from the infrastructure, and to be able to provide even greater visibility into what's happening on the streets for those city operators, not just getting the data from the mobility providers, but other sources, and then be able to provide value back to consumers who are trying to best make use of these mobility options by giving them better visibility overall into how they get from A to B most efficiently, and to schedule that. And all of that requires, again, the movement of data, the processing of data in real time, and the fusion of that data, which we see increasingly happening more at a just in a distributed fashion, closer to where the vehicles and the people are utilizing those services. So with that, I mentioned Sacramento. I just want to conclude with this real world example. We have partnered with the city in a significant way. We see this as a very successful model for deploying smart city technology in conjunction with rolling out 5G technology and starting to experiment with 5G and how it can be utilized as it relates to mobility. And with that, I'll pass it back to you, Gordon.
Thank you so much. This is Gordon speaking, moderator here today, and we're going to take a lot of that substance, a lot of rich substance, and discuss it further. But first, we want to hear from the Chicago perspective. with Brenna Berman. So Brenna, the floor is yours. Thanks for your presentation.
Yes, thanks so much, Gordon. And thanks to Meeting of the Minds for hosting this today, and to everyone who's chosen to join us. So my name is Brenna Berman. I'm the executive director of a nonprofit organization based in Chicago, but working globally, called the CityTech Collaborative. And the CityTech Collaborative really sits in the middle of some very challenging problems that require multiple parties to focus on developing that solution and bringing it to market. So we've all of us that work in this space have sat there and looked at problems in mobility or climate management or economic development, and sat back and said, someone should really work on that. But there really isn't a clear governance model or single stakeholder responsible for that problem. And CityTech really was designed and founded here in Chicago to address those challenges where there isn't a single clear owner. And mobility and the impact of 5G is really shaping quite a bit of our work at this point in time. As Gordon mentioned earlier in his introduction, CityTech reinvents cities through live pilots executed across the world. We work with corporate, academic, and city partners to test that technology and bring it to market to have measurable impact on the residents in our cities. We work across three really specific pillars. The first is the development of city solutions, and we'll look today at two really specific mobility solutions that have been developed and executed, and that we really believe will become enhanced through the advent of 5G. So I want to link that back to everything that Sean was just so gracious to share with us, and talk about how the use of data and mobility is going to have a really strong impact in the near future. We also spend quite a bit of time focused on civic design and user testing. Mobility solutions in particular have a direct impact on our residents' lives, and involving them not only in the deployment of those solutions, but in their design, results in a better output in the creation of that solution. And finally, we spend quite a bit of time bringing together multiple cities to work together around developing and sharing solutions, so that cities are not recreating the wheel every time they try to solve a problem, but really learning from each other and sharing the work that they've done across the world. So earlier this month, CityTech launched an advanced mobility initiative that really is focused on developing a comprehensive roadmap to address the challenges of urban mobility and connectivity. We hear a lot of talk, all of us, I think, on the excitement of autonomous vehicles, or how fantastic or challenging scooters are. And really the challenge for cities, I think, is all of these technologies have appealing and challenging aspects to them, but it's really hard to change that conversation to a city-centric or resident-centric focus, so that what we're looking at is a comprehensive view of how mobility innovation and advancement is really going to improve city life, how it's going to improve the services that cities can deliver, how it's going to make residents healthier and happier, and make it easier to connect, especially our disadvantaged residents, to the resources that they need to live better in cities. So our Advanced Mobility Initiative, which has several corporate partners, several advocacy groups involved, is really focused along several components, but focused on developing new solutions and thought leadership with the city and its residents at the center. It has large components around public engagement to drive holistic solution development and data collaboratives across all aspects of mobility development. It's governed by a vision and set of guiding principles that were developed in partnership with the City of Chicago, which include safety, access and equity, efficiency and reliability, workforce development and economic growth, livability and sustainability, and transparency and public interest. So while Chicago is a focus area for all of the technologies that are shaping mobility today, we really want to make sure that the program that we're driving around mobility innovation is really targeting really targeting outcomes that matter to our residents, right? We are a Vision Zero city, which Sean described so clearly. And how do we make our intersections and our roadways safer for all of our residents, regardless of their mode of transportation? How do we ensure that the solutions that we deploy here result in better access and equity for all residents, regardless of where they live or regardless of how they access our mobility system? Efficiency and reliability is critical for all cities as budgets shrink or go flat. So how do we keep our transportation system efficient and reliable as people's usage of it change over time? Workforce development and economic growth. Transportation is the backbone of how city residents access jobs and opportunities. So as we develop our mobility system, how do we ensure that it's providing that access for all residents across Chicago? And the last two, livability and sustainability. Climate change is at the forefront of both the current and future administration in Chicago. So what role can mobility development play in improving the quality of life and reducing greenhouse gas emissions across Chicago? And from a transparency and public interest perspective, with all of the new data sources that are informing mobility decisions, how can we leverage that data to ensure that mobility decisions are transparent and protected across the stakeholders that are increasing in our mobility system, and engage residents in the core decisions that we're making around investments for mobility and transportation in the greater Chicago region? So these are the guiding principles that are not only shaping the development of the transportation and mobility system here, but also the advanced mobility initiative that CityTech just launched to drive innovation across that system. We're focusing on 4 components. None of these will be particularly surprising, but all 4 of them are necessary to drive innovation for an entire mobility system. So the first is the enhancement of the physical infrastructure and assets of the system. How are we going to retrofit our roads for the advent of AVs, for example? How are we going to ensure data sharing and digital infrastructure that can grow and flex as the sources of data continue to expand? Looking at transportation services and the operating and coordination across existing and emerging public and private transportation mobility services. And finally, the harnessing of emerging modes and new mobility technologies and the interconnectedness of those ever-increasing mobility modes so that residents can actually have a full view of end-to-end journey planning, not just from point A to point B, but from point A to point N, that takes into account all of the decisions that a resident might be making in a changing context. So we will be focusing on those 4 areas. And I thought I would give you just a quick look at our overall timeline for how we'll be actually bringing all of this together for our region. And it includes a strong focus on tactical projects that we plan to align together to make sure we have that comprehensive resident-focused approach through a roadmap. I, for one, will be relatively surprised if we're able to stick to this roadmap for a couple of reasons. Cities are political animals. We're in the middle of an administrative change here in Chicago. We have an election on Tuesday. We hope that this initiative will have the support of the new administration. And as the current mayor put it, when he ran for the first time 8 years ago, no one was talking about autonomous vehicles. He implemented our first bike share program, and scooters were things that kids rode in parks. Fast forward just 8 years, and the new mayor, whoever that might be, is actually facing a very different mobility landscape. And hopefully this plan that we've put in place will help this new mayor actually navigate the complexity of mobility today. But as in politics, we have no guarantee around that. But this is the plan that we've put forth, and you'll notice that includes both solution development and piloting and ongoing projects already around things like curbside management, but also it includes research work working in partnership with the likes of Brookings and McKinsey to actually answer more long-range questions. because while we're making investments today, some of those investments need to be shaped by our understanding of trends that really won't take hold in cities for 5 to 10 years. So we're trying to balance solution development that we can do today based on what we know about resident behavior and ridership today, and developing an understanding of how we think city behavior is going to change 5, 10, or 15 years out. And I wanted to talk to you about a couple of key projects that we've been working on recently and that will continue to develop as 5G becomes available across Chicago. So the first is a demand management project which changed how the Chicago Transit Authority really thought about their ability to manage congestion on their fixed rail lines. So oftentimes, as fixed rail becomes congested, transit authorities begin to think about managing that congestion through major capital investments, which, as we all know, are long-term investments, challenging to execute because you're managing construction projects and certainly not near-term fixes. We engaged with the Chicago Transit Authority and 3 other partners that you see there on the slide: MasterCard, who we all know, Ideas 42, which is a behavioral insights consultancy, and Cineverse, which is a texting platform, to really look at ways to use data to change rider behavior to smooth the peaks and valleys driven by key events that drive congestion on our trains. So for anyone who might know Chicago or be a baseball fan, you would know that anytime there is a night game for the Cubs, there is severe congestion on northbound trains on our red line train stations. And the reason for that is it's our heaviest commuter line, and the Cubs games also start at 7 p.m. So between 5:30 and 6:30 p.m., the capacity on the train jumps by nearly 50%. So not only is that an unpleasant rider experience, the trains are so crowded that it's actually judged as unsafe by the CTA, and it actually increases the wear and tear on the trains and the lines so much that it pushes their capital maintenance projections in by 2 years. So it has real safety and financial implications and customer service implications to the Chicago Transit Authority. So we implemented a pilot project that riders opted into. So because of the payment system that the CTA uses for its riders, they do have enough information to actually reach out via text to potential riders, asking them to opt into a program. And we basically were using a text-based system to push an incentive, either information, just the train is going to be really crowded tomorrow, you might want to change your travel plans. Then there was an incentive around a free ride. If you travel an hour early, if you travel an hour later, we'll refund your ride. And then the third incentive was basically double the cost of a fare. If you travel an hour earlier, if you travel an hour later, we'll make a donation to a specific cancer charity in the amount of $5 if you change your behavior. We ran this experiment over 6 night games, and upon evaluation found that we were actually able to change the behavior of 18% of riders, which in the world of behavior change is actually a significant measurable change and has a real impact on the capacity and congestion of that train line. This is also an extremely low touch technology solution for the CTA to implement, given they have an existing fare system to implement it on top of. So this is a project or an approach that the CTA can implement around any event-driven congestion challenge that they have across their system, be that a baseball game, a concert, a known sort of slowdown for, say, construction on a rail line. And so they're actively using this across their system. And frankly, playing with the impact of different incentives until they refine the system down to where they want it, where they can balance the cost of an incentive with the impact that they want to have to address congestion across the line. This is the kind of thing that will become more responsive with the advent of 5G and the ability for them to access and leverage real-time information. So the reason this is event-driven now is they need to know ahead of time that the event is coming to be able to build the analysis model. As 5G allows city agencies to become more and more real-time driven and push their analysis to the edge, they will be able to use this kind of model to respond to events that pop up, i.e. emergencies in real time, and redirect people basically nearly immediately because of events across the Chicago transit train system. And my slide did not move. The next example that I wanted to talk about is one that's an ongoing project, and I'm going to touch on this briefly so we can open the floor up for some questions, is around delivery congestion reduction. So while most of the time when we talk about mobility in cities, we're talking about personal or resident mobility, this project is actually focused on commercial mobility congestion. And congestion in most cities is actually 30 to 40% of that is due to commercial congestion, the delivery of packages, and that number is actually increasing as, frankly, more and more of us get almost everything delivered to our homes from Amazon Prime and others. But if my mail is any suggestion, it's almost all from Amazon. So the issue or the challenge here is the increase in consumer e-commerce activity, which has resulted in an increase in both the frequency and amount of deliveries to retail and residential locations. And there's very little data that's actually providing any flexibility or sensitivity in those deliveries to the context of the delivery. So basically, there's almost no data available to either the retailer or the delivery companies, be that UPS or FedEx or a dedicated delivery company, around the traffic congestion that may already exist in that area of the delivery. So the goal here is to provide some flexibility in the delivery system across our cities. So the approach we're taking here is collecting and analyzing traffic congestion and consumer demand data to provide insights and flexibility into the effects that consumer demand has on congestion, to build better models both for the retailer and the delivery company into their delivery system. We're looking to quantify the cost of consumer demand congestion and then look for ways to transfer that cost either to the consumer so they can make better decisions about it, or to the retailer so that they can make better decisions about it. So the goal here is both to reduce cost and actually become more responsive to the impact of congestion on deliveries. At this point, we are in that analysis phase and looking to collect additional data both from the delivery companies and from retailers. One of the things that we'll be doing here, which is somewhat interesting, is actually testing different potential consumer demand models directly with consumers to understand their preferences regarding delivery options. So to give you a bit of an example here, one of the companies that we're working with on this project is Walgreens. So currently, most people have a
quick example, just because we have piles and piles of questions. So quick example.
Yep, I will be very quick. Currently, most people pick up their prescriptions from a single Walgreens, but in all reality, there are probably 3 Walgreens that you would be comfortable going to. The one near your house, the one near your work, and one near another location like your child's school or your gym. And all you care about is that your prescription is at that Walgreens at the time promised. From the Walgreens and the FedEx delivery perspective, at any given point in time, one of those locations is actually much cheaper than the other 2, but neither Walgreens nor FedEx has the data-driven insight to know on a given day, say Thursday, which one of those 3 locations will be the cheapest when you need to pick up your prescription. So that's the model that we're trying to build, the model that tells them on Thursday at 6 o'clock, the Walgreens by your kid's school is the cheapest, and that they have the ability to tell you that that's where you're going to go. I think I can probably skip that last slide and turn things back over for questions from the audience. Thank you all so much for your time.
Brenna, thank you so much. A lot there to digest, and we have tons of questions, which is always a good sign. First question for you, Brenna, is from Winston here in Silicon Valley. How are CityTech and the City of Chicago utilizing the newly deployed citywide IoT network that was deployed previously for the City of Chicago's Network Streetlights program? Can you talk a little bit about that?
So the short answer is that project is only about 2/3 done. So we're not using it yet because the project is still underway. The longer answer, once it is fully available, is that the city anticipates using that as the base architecture for any number of public safety services, integrating that into the city's Vision Zero plans to drive calibration around, especially near misses, very much along the example that Sean pointed out. We also have a second publicly available IoT network in Chicago based on a program in partnership with the University of Chicago and Argonne called the Array of Things, which is a environmental sensor network, which we're currently using to actually drive specifically improvements around the inequality of air quality across the city, which we're using to drive right now mapping for better routing around air quality for children with asthma. So we have two networks available to us in Chicago.
Good. That's very helpful, and I'm sure Winston will be in touch with you about that directly.
Absolutely.
Sean, back to you with a question from Corey at Hosselert, who's based in Chicago. He's asking, with cities still rolling out LTE, does Verizon find that cities are ready to make use of 5G and the V2X technologies, the vehicle to whatever technologies today? And he then asks, how long do you think cities will continue to focus on LTE until a switchover happens to the new cellular?
Yeah, it's a great point. I'm glad Corey brought it up. So to be clear, many solutions are available today, with the 4G LTE technology, and we continue to invest heavily in the augmentation of 4G LTE, and it is not going away anytime soon, and is synergistic with 5G. And so really what it comes down to is that as we roll out 5G, there will be use cases that require 5G and MEC, the mobile edge compute in particular, and we're going to invest time and energy to validate those use cases and know that they will be available as 5G rolls out. And yet there will be a myriad of other use cases that can be addressed today with the existing 4G technology. So, and I would just say that it's really the wireless communication companies like Verizon who are making that investment as opposed to the cities directly. We're out there every day, making coverage better, both for consumers and businesses, but also to address some of these mobility and smart city use cases.
All right, that's helpful, and thanks for that. Staying with you, Sean, Richard in Tejon Ranch, the development project in Central California, he's asking, what about 5G in small communities like theirs? Is there a plan, or is that still TBD?
Yeah, so I mean, 5G will get rolled out over time based on the overall needs of the community and of course sort of the benefits that can be derived from 5G. We have started with a set number of cities that we've been public about, including most recently Chicago, Minneapolis as our first 5G mobility cities where we're going to launch the mobility service. But we are, we're committed to a nationwide rollout of 5G, and so with time, we will clearly expand and go far beyond some of these initial cities that have been launched.
Good, and this is a question for both of you, and I'll start with Brenna. This is about the many questions that have come up around privacy and who has control, especially when you're using data in real time, like the Night Game Alerts project in Chicago, and you've got partners like MasterCard, large corporates who have access to data, whether it's data that they're creating in their own systems like the MasterCard transaction system or data in the cell network. First, Brenna, what are you doing around the discussion and policies for Chicago around the privacy of the data and the security of the data?
Yep. No, that's a great question. I'm really glad that it was asked. So data privacy has been a really serious discussion in Chicago, starting with the array of things where we have devices in the public right of way capturing or potentially capturing PII. So there was a very serious discussion about data privacy there, and the way that was handled is available on that website for anyone who's interested in how that was addressed. Particularly for the Cubs pilot, we were using data, rider data that was captured by the CTA through their payment system, but only they had access. The CTA had access to processing that data to target, the riders that were on that particular line at that particular time, and those results were handed to the team here at CityTech in a blinded way for the project. So we were careful about how that was handled. And then once the pilot was done, the solution itself was handed over to the CTA to implement, within their system as a public authority in how they treat data with their customers. So we don't have any access to that on our side. So that's how it was handled in that particular case. We actually don't hold or maintain any resident data here at CityTech by design, because we don't have that authority or the stewardship to do that.
And Sean, what's your thinking at Verizon about the 5G networks wraparound policies for privacy and use of data by third parties?
Yeah, I mean, I think that, of course, it is super important, both privacy and data security, because they're interrelated. And we in the Smart Communities team spend a lot of time and energy focused on how do we maintain the level of data privacy and security we need on a solution by solution basis, because it's not a sort of one size fits all. Now, as it relates to 5G, I think 5G is an enabler for data. It allows for the transmission and the processing of more data, but it's really it's how it's implemented with given solutions that's critical. And so a couple of examples, we implement what's called privacy by design. So when we deploy a mobility related solution, we are only interested in the anonymous movement of the vehicles. And so we it's similar to what Brenna described. We purposefully do not want to capture, maintain any PII, personally identifiable information. Rather, we want to, take the raw sensor data, and only then we extract the data that is relevant for the specific solution. So intersection safety analytics, Vision Zero, we're really only interested in the types of events that are correlated with pedestrian accidents, like near misses or jaywalking and so on. And so, that's the data that we collect, and we use it for the express purpose of meeting that solution objective. Now, if we do collect information that that does include PII, then it's on behalf of the agency that has the ability to use that data, like the police department. If we're serving as an extension of the police department by providing them with additional tools and technology, it's really the police department that's using those tools to that end. And so it's a real case by case basis that we dig in and really make sure that we're meeting the objectives of that, the requirements and the objectives for that particular solution category.
Great. And a follow-up question. Several of the city executives participating have asked a variation of the following question. How exactly is all of this data from all of these different sensors being aggregated and made available to third-party application developers who presumably will then build specific apps for end users like citizens and residents and visitors of that city? Can you talk about Verizon's thinking in the Sacramento context or other cities? And then maybe I'll ask the same of Brenna to talk about the approach that may be underway in Chicago.
Yeah, I think this is an exciting opportunity, which is to be able to make that aggregated anonymized data available to developers, both within the city as well as any third parties that the city wants to choose to make that data available to. And what we've been doing in that regard is developing what we call a city data insights platform, which is effectively a managed data lake, because it's very difficult. It's not as simple as just saying, hey, here's a data warehouse, and here we want to make that data available to developers. So here's a set of API keys. This is very rapidly evolving technology that requires a pretty sophisticated set of tools, and that cities in general want support in that regard. And so what we've done is started to work with some initial cities to identify the data sources they want to make available, and we bring them in and bring those data sources in, and we have a set of data ingestion tools to make that easier. And then we work with the city to initially address some use cases with analytics and AI and machine learning tools on top of it, and have our team help with that. And then ultimately we'll transition that into a path where developers can also come and access through a robust set of APIs and credentialed access to the relevant data. So that is still work in process, but we see as a really exciting area of development for us. And we actually presented with the city of San Jose and one of our partners, Amazon Web Services, earlier this year. Actually, it was late last year. We presented some of the work that we've done around optimizing the deployment of emergency vehicles around the city, and using a number of different data sources to help with that.
And Brenna, you get the last word here, because we're getting close to the top of the hour. Any thoughts in Chicago about this aggregation to empower the use of the data beyond the immediate demands of the immediate project per se, like night game alerts?
Sean's technical answer was fantastic. I think there's an interesting policy question that each city is going to have to answer differently. Chicago has a very strong, open data history, so we tend to go down the path of making as much data available to our developer community as possible, and supporting the general economic development gold dust that comes from doing that. That becomes a more expensive undertaking as the access to that data becomes more challenging. So cities are going to have to sit back and look at how best to, what's the best model for supporting the access to that data, and how closely they want to get to the monetization needs of that data to support the access to it, because the balance changes with the complexity of the data access.
Well, and having somebody who's steeped in the city governance challenges in Chicago, and somebody like Sean who's steeped in the technical and non-technical parts of this, really helped round out perspectives today. And I want to thank you both very much for participating. I want to suggest to everybody, stay online. A short survey is going to pop up once you close your browser. We really appreciate your feedback, and we hope to see you at one of our upcoming events, which are all available in the events section of our website at meetingoftheminds.org. A big thanks to you both, the presenters today, for taking the time and putting the thought behind the presentations. And Brenna and Sean's presentations are available to you when we post this webinar on our website, with a link to PDF for download of the two decks. So thanks again. Take our survey in the next moment if you have an opportunity. That concludes our session for today. Have a very good day for the remainder. For those of you in Europe, have a very good evening, and thanks again for attending. That's the end of our session.